Okay, great. Hi, my name is Liz Hoy, and I work in the NASA Carbon Cycle and Ecosystems Office. And this is our monthly webinar for the Above Science Cloud, which we use as a forum for users of the Science Cloud to come and ask questions about the Science Cloud. And we have members of our partner organization that's running the Science Cloud online with us. So that's the NASA Center for Climate Simulation, NCCS. And they are here to answer questions, and I usually start off with an informational presentation by someone who is doing something on the Science Cloud. So one of the newer capabilities that we've added to the Science Cloud in the last year has been the idea of we have web services. We have an ArcGIS web portal that's on the Science Cloud that any Science Cloud user can use. Currently, we only have a few people that are really trying it out. So we wanted to talk a little bit about this ArcGIS portal, or portal for ArcGIS, that's on the Science Cloud, and an application that exists within that portal, which is the idea of a story map. And so we have speakers today. We'll talk first about what a story map actually is, and then we have JJ Frost, who's an above PI who works up in Alaska, and he's going to share a story map that he's created that is pretty Where's Walden? We're going to have to find that. And then Carly Robbins was an NCCS summer intern this past summer, and she's now working on her master's in GIS at Clark University. And she's going to share a story map that she created this summer. And then we have time too. Jim Shute who is an NCCS, he's kind of the applications architect who's helped to install Arc Portal on the system, and then also has really done a lot of the in figuring out how we can use it, and he's helped some groups really start to use that system. So he'll talk a little bit about. So I'll just give a brief overview of what a story map actually is. So we are using ESRI's product. That's ESRI makes ArcMap and ArcPro, and they also make ArcGIS Online, and the corollary to that is the portal for ArcGIS, which is it's like ArcGIS Online, but it's hosted by our own systems here at NASA. And so with a portal account, you can create your own story map. So basically, you create a map in ArcMap that you want to share with others, and you can make it a web map, which means that you're sharing it with other people over the web. Add text to it. You can add images. You can add, videos, and then you can share that entire package out with other people in a way that I think works very well if you're trying to meet with stakeholders or explain something to general public. It can be really nice for that. So these are just a few examples that I'm showing on the page here, where that ESRI actually shows on their website. There was someone did a map of Hurricane Florence damage, and you can. And with this thumb, they have kind of a time slider, so you'd actually be able to kind of take this window, slide it back and forth, and pan around and look at damage. Else has used a story map to look at sea level rise in Miami-Dade County. Another group has used a story map as a way to creatively show where storm surge hazards can be. So there are a lot of different applications for story maps, and we will show you some today. I wanted to mention too, story maps, you can create them on the Science Cloud. So I just pulled this screenshot out today. It took me 3 clicks to get to this page. You would log into your portal account. I'll tell you how to get one if you don't. Say you want to create a new web app, and the option is build a story map. There are these templates that are already available in portal for ArcGIS that you can use to get started on your story map. So it doesn't doesn't require a lot of programming, any programming or coding to do this. You can use data that you're already publishing. It's not actually too bad of a process to do. Want to mention before we get started, if you're wondering, as you hear these presentations, man, I want to get started on this. I want to use a story map to talk with other investigators or to talk with stakeholders. Where do you start? Well, first you need to request an NCCS account on ADAPT or the Above Science Cloud. Many of you should already probably have these accounts, because if you're calling into this webinar, it means you got the note from me, and I only sent it to people who have Above Science Cloud accounts. So, but if you need to get an NCCS account on ADAPT, which is the Advanced Data Analytics Platform, of which the Above Science Cloud is a part of, you can go to this website here, Science Cloud Setup, to see the instructions on how to get an account. And when you request the account, you can actually just tell them you would like to get access to the Windows environment and Portal for ArcGIS, and they will create your account. However, if you already have an NCCS account and you now want to add Portal for ArcGIS to that account, you would submit a support ticket to support@nccs.nasa.gov requesting access to the Windows environment and a Portal for ArcGIS account. And they will help set you up with that account. If you need access to the development environment, you can make sure to mention that in the ticket. I don't know that all of you will need access to that, though. Wouldn't worry about that as much at first. Then if you do get stuck, the GIS team, of which Jim Shute is one of them, can provide assistance via WebEx if necessary. So they can even go on, I have used, Jim has helped me before with that, and he's great at that. So without further ado, we'll let Dr. J.J. Frost start us off, and he's going to talk about a story map he created for the Emmonak community. I think I've pronounced that wrong. I put a link to his story map here down at the bottom, and I think he has some other links he's going to share. And we'll add that to our presentation that we post online afterwards. So JJ, I'm going to stop sharing, so then you should be able to share your screen.
Okay, thanks, Liz.
As JJ gets going, just a note, if you're not the speaker, make sure to mute yourself. And also, if you have questions, you can type them into the chat box or raise your hand or just ask. We try to have this as a forum for open to chatting with.
Great.
All right, thanks. Go ahead, JJ. Thank you.
All right. Well, thanks, Liz, and good morning, everybody. For those that don't know me, I'm J.J. Frost, sitting here in Fairbanks, Alaska. And what I want to share is just a brief overview of some story maps that we've created as part of our work on the YK Delta through an Above project that Liz alluded to. And just in the title slide here, I want to emphasize, that these story maps are, they're interactive and they are useful for a number of different purposes. We're starting to see something like a story map emerge, both through ESRI and, some of the examples Liz showed. And also I see it more and more in the popular press, on online editions of the New York Times, for example. You can look at kind of before and after satellite views of areas like affected by Hurricane Florence or places in North Korea or, you name it. So it's really an emerging tool, and I think it's a really exciting one, and they're actually pretty simple to put together. So just things I want to touch on, we already kind of talked about, what is a story map. I'll give some example, and it's just one example. I mean, there's many ways to do a story map. I'll show you one that has been effective for some of our project activities. I'll talk very briefly about some licensing considerations when you're using imagery, digital globe imagery. As we all know, we have to be respectful of user agreements and limitations. And then probably the most important part is just going to be kind of a self-guided tour where everybody on the call can explore one of these story maps on their own. And actually, in the chat window on Adobe Connect, if you can see that, I put a link there. So what is a story map? We already talked about this, so I'll just kind of skip by. But it's yeah, it's interactive, and it's obviously using geospatial information, and you're trying to reach a broad audience. And depending on what you're trying to accomplish with the story map or where you might be at with your project, you might want to distill scientific results. So basically take findings that you might have published, say, and distill that in a way that you can communicate it to the lay people. I think we all know that if we work with geospatial data that there's so much information embedded, spatial context, local context, as we'll see here in a moment with some of the story maps I've developed for specific villages. And they're great tools as a springboard for discussion, like if you're in a meeting and you're able to work on site with people who might be using it. You can reach people of just about every age group. And it could be for purposes of something like just outreach or just awareness to let people know what you're doing. But it can also be a tool for more formal activities. And I guess one way to put that is community participatory GIS. So with the project I'm working on in southwestern Alaska on the Yukon-Kuskokwim Delta, it's an area that has the big region and has a lot of communities. And reaching those communities, reaching people living in that region has been very important in this project because we're interested in environmental change and what are the impacts of that change. And there's a lot of people living out there. So early on in the project, it was really obvious that we needed to work on tools to connect with people and find an effective way to solicit input and feedback from locals. So it's just some examples of some of the communities, and without dwelling too much on the YK Delta, but this is a region that is, I suppose you'd say, a target-rich environment when it comes to environmental change. And two big reasons are shown right there. It's the low-lying area, big coastal zone, and then also permafrost is common, but a lot of it is thawing. And we're trying to let local concerns, expectations, and observations of environmental change inform our science and how we direct our resources. So we're really trying to promote that interplay. Here's just some examples from two villages. One we just looked at was Chivac, and this one is concerns a village up on the Yukon Delta, Emmonak. There's some really common forms of environmental change that people see on the landscape and tell us about, and we certainly see it in remote sensing as well. The ways that we've been able to glean some of this information from people, one is just getting out on the landscape with locals. This is the guy that was just driving me around on the Yukon Delta just about a month ago. So that's a great way. Story maps shown there in the bottom left, and then we're using both of those, information from both of those, to organize and direct a knowledge exchange meeting with the elders. And the story maps actually will be important there as well. So, okay, so this all started actually before I was working on this above project. I worked with the Bering Strait School District in Western Alaska to help develop a science curriculum for K through 12 students. And so that's kind of where this story map idea that we'll look at was born. But then it right on the heels, becoming active on the YK, it was obvious this would be a great tool. So that map just shows you the villages where we have story maps, and if anybody wants, they can visit the story map for each of those. And the basic idea is, this is just shown in sort of a poster summary, is to look at a modern image that we see on the right and then co-register a historical photo. And it provides a way, certainly a way I've conducted a lot of my science in a retrospective approach. But there's so much information embedded in this imagery that a lot of people who live in a particular place, like in this case, Kotlik, they have a great deal of local perspective, and they recognize features. It can be a really interesting way to promote discussion. And so just a brief cookbook for this style of story map. It's really pretty simple. I wouldn't say there's necessarily any results per se, scientific results, but I'll come back to that here in a second. Instead, this is just a tool, a very interactive tool for people to explore environmental change on their own and facilitate discussion. So with that setup of modern and historical imagery, there's some simple steps that goes into that in GIS. Fairly straightforward, co-registering an old air photo to a modern digital globe image. I'm not going to talk too much about the technical aspects of doing this in ESRI, but I can take any questions about that if people have specific questions. But the main thing is there's a lot of different templates and different tools that you can choose from, and so it's wise to explore those and consider, what is it you're trying to accomplish with your story map, what's the information you're trying to convey, and what's your audience. And so you see a little Waldo character, and that just alludes to the fact that at its inception, these story maps were designed for students in K through 12. So we'll see how the Waldo fits into that. Okay, let's see. So I mentioned science content and results, and this is just a figure from a recent paper we had, and it's obviously this is a science figure. You see things about probabilities and lots of abbreviations and acronyms, but there is a map here that actually does have straightforward content. And in fact, it's depicting the extent of permafrost in a region near one of these focus villages. So the idea here is simply that once I've got my basic story map with old air photo and modern satellite image, you can see it'd be fairly straightforward to add additional elements that reflect science results and other forms of information. Let's see. So here's the current story map villages again. And hey, there's a lot of places in Alaska, and these are all different villages in different regions, locations, environmental settings, and virtually all of them have pretty important environmental change processes happening nearby. So I suppose this is just a little personal aspiration, is to one day see a story map created for just about every village in Alaska. So with that, I think I would invite anybody on the call just to follow that link to the Emmonak story map. And there's a number of other ones, these other villages. Many people maybe are familiar with Shishmaref, for example. It's a village that's really kind of, if you will, a poster child for coastal erosion in western Alaska. There's a lot of considerations with relocating that village. So anyway, you can explore these at your leisure. Let me get out of the PowerPoint, and I'm going to go over to the Emmonak story map online. So I've been talking a lot about this style of story map. Now you can finally see exactly what it's about. Rather than the poster format where you just saw an old image and a new image, one next to the other. In this case, now basically you've just got a digital globe base image across most of the frame that's just from a few years ago, and the village of Emmonak there. And then what I have here is a loop tool. And that is basically forming a little window into the past, if you will, where you're looking in that as co-registered air photo from around 1950. And you can clearly see, obviously, Emmonak, the village as we know it today, did not exist. So that's obviously one major change on the landscape. But then there's many others in this region. And again, you see it's framed right on the village. And the idea is that, hey, whether your audience is a student or an adult, an elder, immediately there's a place they're extremely familiar with, and they can zoom in, and as I'll often do with young students, is I'll just first ask them to kind of get them warmed up to the idea of using this to just find their house, or find grandma's house, or find the school, and that's how, I guess with a younger audience, it's key to just get them engaged early, and then what I've found is once you do that, then they start finding all kinds of things on their own. So this is, you can basically just pan around and use that loop tool to look into the past. You know, there's other variations of this. You can use a swipe tool where you kind of swipe one image by the other and you can see a bigger area. But this loop tool seems to be pretty effective, and early on when I was visiting Emmonak, I actually learned something very interesting from the locals. There was obviously no village, but I was talking to the guy, and he quickly found this little camp here. These are basically a little hillside camp with some canvas tents and stuff, and he quickly recognized that as his grandfather's fish camp. So it's pretty interesting. But that's just an example of what you can kind of get when you start talking to people with a very local, you know, a story map framed around a place that people are going to be really familiar with. So if you're out there exploring, you know, what you'll quickly find is when you get to the edges of the area here, there, you know, I only co-registered a few air photos to this, and you're seeing the edges of one there. So it's a little messy in that regard, but if you just pan around, you'll quickly find a lot of changes. And just, I know this has actually tripped people up in the past. The change has been so dramatic here in the course of the Yukon River, but if you're using the story map, you'll see things get a little confusing here. But what's happened is that channel of the Yukon has migrated substantially, and a lot of that has occurred in an area where you're basically looking at overlapping or corners of different air photos. So it gets a little confusing there, but be assured that change is real. The river has moved a lot there. But just one other thing, I mentioned the Waldos, and it's just an example of, you know, depending on your audience, you may need a little hook to get people engaged. And the Waldos were actually, that was an idea that one of the school teachers suggested. You know, put something that doesn't belong in the frame and let the kids try and find it. And so at first they're in this quest to find Waldo. But once they find Waldo, like here's one. I put the Waldos in a strategic location where there's some example of environmental change, and you'll see there's a little number there. And there's, I think in this case, 4 or 5 Waldos, and they all are located on a particular location that illustrates the form of environmental change. In this case, it's obviously bank erosion of the river. This is the site of an old salmon cannery that's very much gone. So the Waldos were helpful because to give the kids something to focus on first, and then once they kind of get engaged, now they're off and running and finding other things. So, yeah, I guess I'll leave it at that. Again, this is just one example of the story map. You see many others that have a different format and also different kinds of content with ground photos or other kind of derived maps of things on the landscape. But I think I'll leave it there, and welcome to take any questions. I can also, if people like, I can go back and put these web links. Like I'll go ahead and put the Shishmaref link up on the chat, so it might be easier for people to let's see if I can get back to the
JJ, I'll also, after this is over, I'll get this presentation from you if it's okay.
Okay.
We'll post it on the website.
All right.
So we're recording right now, and then we will put the PowerPoint up at the end so that you can go back and check things out too. Thank you, JJ. I really like that story map. You know, it's simple in a way. It's just showing this kind of time slider through this lens, but I think it's a great way to show school children how to look at a map and pan around. And I think having the Where's Waldo in there is just a great teaching tool. You know, I think I have little kids myself. I could see them looking at this map, and I should show it to them when I get home. They'd be interested in looking at it.
Well, and you know, I think that's a good. You mentioned, I think, the word simple, and I kind of respected the adage, you know, less is more. The imagery alone is, you know, there's so much to see in there, and again, with the idea of engaging, you know, young people, you know, you don't need too many bells and whistles, or you know, you don't want to make it too complicated. So that's a good consideration, and you know, you can obviously, what I didn't mention is all of this obviously is over the web, so it's easy to share it with people. People can try it out and give you feedback. So, yeah, so.
Hey, JJ, I have a question.
Sure.
It's Peter. So in the villages, is the internet bandwidth an issue for use of something like this at out in a remote community, or are they pretty much dialed in through some satellite link that's fast enough to support these kinds of apps?
Yeah, that's an excellent question. So, every village is a little different, for sure, when it comes to bandwidth. And actually, one of the main forums where I've used these in person has been in schools, and very frequently the fastest internet is at the school. These village schools, mostly, and again, it would vary by village, but in my experience, the schools, they have internet bandwidth and capabilities that are sufficient for this. But that's an excellent point. Depending where you're meeting, if you're in a village, if you're not at the school, yeah, this is something you would definitely want to be aware of before you got there. Like if you're going to be able to use this, or if you're going to need to instead, just switch to some sort of offline version, or maybe just work within ARC or something like that. But yeah, connectivity is a big issue for a lot of these remote areas.
Well, thanks very much, JJ. I wanted to mention too, JJ brought this up, but he was using digital globe imagery, and he mentioned anyone who tried to do something like this would need to be very careful of any licensing agreements. So JJ actually purchased this imagery for his project to use it in this way. He purchased it from a vendor who sells digital globe imagery. So our next view license is a little different with the imagery that we have, and we're currently exploring if something like this could be done through the license that we have with the imagery. But JJ actually, his project purchased this imagery for his purposes. So just an extra little note on that. Thank you again, JJ, and I guess we'll move on to Carly now. Carly Robbins was an NCCS summer intern this year, working with Jim Shute, and she is going to talk to us about a story map that she created using the NCCS ArcGIS for Portal for ArcGIS. And so JJ did not create his map on the Science Cloud, but it could be done on the Science Cloud. And here's an example of a map that was made on the Science Cloud, but not of the above study domain. But it just is a way to show you other options that are available for you on the Science Cloud and ways that you could create these kinds of maps. So Carly, I'll go ahead and here, you had 2 slides, so I'll let you go ahead and take it away.
Thank you, Liz. As Liz mentioned, I was an intern at NCCS this summer, and my mentor was Jim. And my story map was a story map showing barn swallow distribution and how climate has been impacting them. Can you go to the next slide? Thank you. So I am not an expert in the technicalities of ESRI Story Maps. That's more of Jim's expertise. But I created this flow chart to give you a basic overview of how I created my story map. So first I did all of the analysis in ArcGIS desktop. Then I connected to the ArcGIS server. I shared all of those data layers that I created in ArcGIS desktop as web services. And then I created maps within Portal for ArcGIS using those web services. And then using those maps, I built story map apps with the templates that ESRI already gives you. And with those story map apps, if you want, you can embed those into a final story map, which is what I did. And now I will show you my story map and kind of the science behind all of the analysis and some different ways that you can present your results.
Carly, did you, let me interrupt for a second and ask, when you said you did it with the ArcGIS desktop for creating the original layers, did you do that in a Windows VM in ADAPT, or did you do that in ArcGIS desktop with your remote machine? I mean, your local machine is physically with you.
I used a virtual machine using guacamole.
Oh. Okay, cool. Thank you.
However, you would not have, you could do it on your own machine if you had ArcGIS desktop on your own machine, and then you could share it to the NCCS portal as long as you had a publisher access through that. I believe that's right. Right, Jim? I'm not hearing Jim, but I'm pretty sure I'm right.
Sorry, I was on mute. Yeah, that's correct. The only issue might be is if you have some sort of like large raster that you're trying to share, it would want to copy that up to the server. So there might be other ways that you might want to navigate that particular piece of the process.
Thanks, Jim.
So my study was on examining the effect of Earth's rising temperatures on the species distribution of the barn swallow. The barn swallow is very ubiquitous. It's in Europe, Asia, Africa, and the Americas. They're not endangered. So I chose this species because there was a lot of data available. And in this study, I used different spatial statistics to measure the difference in the geographic distributions over time. And finally, I ran a binomial regression in order to establish the relationship between the climate variable and the bird count. So on this first page of my story map, I just have an overview of the species and what would be the abstract of the study. And for the second page, I have the study area, which is the entire state of California, shown in red. We also created a 100-mile buffer to account for birds coming in and out of the state. And the study period was from 1980 to 1997 and 1998 to 2017. And the reason why we chose these particular dates was that the climate reanalysis data goes from 1980 to 2017, but also after the El Nino of 1997-1998, climate really started to change, which we can see in this plot of temperature anomalies. So after 98, you really start to see an increase. The data that I used for this study, the bird data, it came from eBird. eBird is the world's largest biodiversity-related citizen science project, and every single year, the contributors submit more than 100 million bird sightings worldwide. However, this is presence data, so there could be birds in places that do not have points. It's just that people were not there to spot them. So on the right, you can have different tabs for the different years, and you can click on the data points, and you'll see all of the information that would show up in the attributes table. So we have longitude, latitude, bird count, and observation date. And that's the same for the second time interval of our study. But you can see that in the more recent years, there have been a lot more observations because it's been easier to submit data. Now, eBird, they have a mobile app where people who are going birding, they can very easily submit that data. The climate data that I used was the NOAA Climate Forecast System Reanalysis, or CFSR. The particular variable that I used was the monthly mean surface temperature, or TAS. And again, this data ranged from 1980 to 2017. And on the right, I have a video of this data. And I chose to show it as a video because when you embedded the data into the story map, it would load way too slowly. So I'll play this video, a little bit of it for you. And this is a screen recording of the time-aware Mosaic dataset in Portal. So we were using Mosaic datasets, which is a data model to manage a collection of rasters, which can be viewed as a mosaic image. And we were using this data type particularly because it can be shared as an image service and viewed on the web. So for the analysis of my study, I looked at whether the distribution of bird sightings had changed over time. And one helpful tool that I used was the Swipe app. So on the left in red, this is data from the earlier time period, 1980 to 97. So this ellipse is a standard deviational ellipse, which measures the trend in the distribution. And this method calculates the standard deviation of the x and y coordinates from the mean center, which defines the axes of the ellipse. And the shape of it will indicate if there's a particular orientation. So in the middle we have the mean center, and if you click on it, you can get the x and y coordinates of that. If you click on the ellipse, you can also get the mean center with the center x and y. You also get the x standard deviation, the y standard deviation. Now if we swipe it, we'll see the same thing, but for a second time interval. And if you swipe back and forth, you can see that the blue dot is actually moving north, which indicates that the mean center had moved north. And also, the shape of that blue ellipse is a lot skinnier, which is also indicative of the birds moving north. The next analysis that I did was I looked at spatial dependence. So I wanted to see what is the pattern of the distributions. You know, are the birds clustered? Are they spatially random, or are they dispersed? So the statistics that I used to measure that was the GEDIS or GI star statistic. This is a Z-score, so once you use the hotspot analysis tool in ArcGIS, you don't have to do any more calculations. And a hotspot is a feature that has a high value and is also surrounded by other high values. And then a cold spot would be the opposite, where you have a low value surrounded by other low values. So on the right, I have another swipe tool because it's so useful for comparing two different time periods. And if we swipe back and forth, we can see that during that second time interval, there are a lot more observations because more people are using eBird. And another thing to note is that all the clustering that we see is in areas where a lot of people live. This is a problem with crowdsourced data. There's sampling bias because of the people that is collecting the data. So one other thing that we can notice from this is that during that second time period, as I highlighted with this red circle, there are some new hotspots north of the California border, and that may be due to conditions here becoming more suitable for barn swallow populations. But we can't say for sure without doing any other statistics. So to measure the impact of climate on the shifting barn swallow distribution, I did a negative binomial regression. And I used this in particular because I had count data, and there was over dispersion present in the data. So in other words, the variance was a lot larger than the mean. The mean was about 8 barn swallows, and the variance was about 170 barn swallows. On the right, this is another story map app embedded into the final story map app. So we have a histogram of all the barn swallow accounts, and then I also presented the results of the negative binomial regression. So for every 1 degree Fahrenheit increase in average temperature, the barn swallow count is expected to increase by a factor of 0.037. And this regression showed that the average temperature was a statistically significant predictor variable at a confidence level of 0.05, as indicated by the p-value, which is small. However, the distribution of barn swallows is probably not only explained just by the average temperature. On a more localized scale, there may be mechanisms like predation or competition that could help to explain this phenomenon. And there might also be other climate variables like precipitation or wind that could help explain this phenomenon. But my time at NASA was pretty limited, so I had only had the time for one variable. However, the statisticians and researchers at the Cornell Lab of Ornithology who manage eBird, they developed some abundance models which provide insight into the full annual cycle of bird populations. So they took the eBird data that people submitted and they combined it with some other environmental variables to produce predictions of bird locations for every single week of the year. And they also predicted 2 areas that people had not submitted from. So I have a video of this animation. And the last page of my story map is it is the website of Create, which is where you can get the climate data.
Thanks, Carly. I like showing Carly's even though it's not about our above domain because it does show you how you can use an interactive map to showcase your data and your analysis, and you click through almost like you're clicking through on a slide. It's like kind of like a mini hyperwall talk in a way. There's just a lot of different things happening. So I want to thank JJ and Carly for their talks today. Jim, what do you think? It's already 1:48. Should we save your part for another day so we have time for Q&A?
Sure, that's fine.
Okay. So I wanted to give people an opportunity to ask any questions of JJ or Carly about story maps or story maps on the Science Cloud. And then after that, we'll have just some general Q&A on the Science Cloud. Anybody have any questions for JJ and Carly? What I wanted to know, JJ, was how did you actually put Waldo into the map? Did you just add
Oh yeah, that's a good question. So let's see. You know, I'll have to confess it's been a little while since I actually did this. Incidentally, I would be remiss if I didn't acknowledge the help of my lovely wife, Shalane, who helped me with that. But yeah, I think as you noticed, the Waldos, you know, they didn't, you know, rescale. For example, like you know, it was a small object, and then as you zoom in, Waldo gets bigger, as opposed to having Waldo in there as a feature that would just stay the same size regardless of the zoom. If that makes any sense. So yeah, we had to do, and then obviously it's another thing as well with the numbers. So they're just basically were embedded into the historical air photo raster. So I can't actually recall exactly what tools we did to do that, but you know, fairly straightforward. We basically created a new raster that had the Waldos embedded on that air photo, because obviously we didn't want Waldo to show up in the base image, the digital globe base image.
Sure.
So there actually was a little bit of, you know, I mean, nothing really fancy there, but there was a little bit of work that went into getting the Waldos to look right, if you will. Yeah, and incidentally, you know, when I guess you file this under a similar theme as the considerations with digital globe imagery, but in the beginning with the Bering Strait School District, just to make sure everything was kosher, you know, they checked into whether we were on solid ground using Waldo, because obviously Waldo is, you know, yeah, so there weren't any issues with doing that. But
it's good they checked.
Yeah, I guess. I guess the other thing with the story maps I showed is, you know, those are not story maps that you're going to be able to just find online. You know, Googling. Obviously, if I give you the link, you've got it. But you know, I guess. Yeah, I guess with the NextView license and so on, you know, that might be one thing is how is this information being shared? If it's just widely available on a search engine, you know, I'll let Liz speak to that actually. Yeah, it was just a concern of ours was to make sure we were on the right side of the law, or the user agreement. So we were a little bit careful in how we shared the link to the story map.
I think that's the right call, and we're looking into it now to see if, with our license, if we'd be able to do this same kind of thing with others. So we can keep this group posted as we learn more. But it's such a great teaching tool. I love how you've used it for that. Carly, I had a question for you too. How much time would you say it took you to make the story map versus actually to do your analysis? Was the story map a big investment? I know you mentioned you'd make one part and then you'd embed it into another part.
Well, the story map was probably the shortest part of my project. My internship was only 10 weeks, and the first 2 weeks was just trying to get a computer and an account. And then I still had to figure out what my project was and do the analysis, and I didn't really start the story map until the last 1.5 weeks.
Okay.
So,
I think it
so
looks
Liz,
amazing.
one thing I'd like to add to that is, you know, a lot of that had to deal with multi-dimensional net CDF data, like the temperature at surface stuff that she used for each time slice. And we already have kind of a methodology for extracting and republishing that data, so we were able to leverage that, which saved Carly a lot of actual, like, any possible coding time. So it kind of jump-started the actual data prep piece, so she could focus more on that really good analysis that you guys saw.
Great. Peter's online, and he said, Carly, you did a lot in 10 weeks. It's very impressive, and it really is. Thank you for sharing.
Thank you.
Okay, well, we only have a couple more minutes left, so if anyone has any other questions for JJ and Carly, feel free to ask those, but then I also like to see if there are any other questions just about the Science Cloud in general. System updates-wise, I think we were supposed to have a downtime, but that was, I think, canceled. I don't know, Jim, if you have any system updates that we should be making sure to mention to people today?
Yeah, they're going to try and resolve some hardware failures or possible hardware failures that are that could pop up. So they're doing a little bit of maintenance on that. I believe tomorrow morning, but if you haven't seen anything from NCCS, they may be postponing it. But I know that they're expecting minimal impact across the platform.
All right, and then did anyone else have questions about, or any questions about just using the Science Cloud in general?
Yeah, hi, it's Chris Cosgrove here, just following up from my email. I guess I have a question about running Fortran models on the Science Cloud.
Yes, Chris, I'm glad you did call in about that. And I think we've gotten your, so Chris is working on running some models on the Science Cloud, and he's using Fortran, and needs a compiler to do that. And you sent in an NCCS ticket, and I don't know, Jim, if you've seen that, or you know who's maybe addressing that?
Let me see if I can take a look. I don't have much firsthand knowledge myself, though.
We'll make sure to figure out who's going to follow up with you on that one, Chris. While Jim
Sure.
takes a look in his system to see about that, I just want to remind people that if you have questions about Science Cloud setup, here's the website for that, love.nasa.gov/sciencecloud_setup. And then if you ever have any issues, you can always go to support. You can always send an email to support@nccs.nasa.gov. You submit a support ticket, and they're very responsive to those. So I'm seeing some notes in the chat box here. It looks like Ellen Salmon, who is one of our NCCS collaborators, says, Chris, we do have a ticket open for you, and so they are working on figuring out how to respond best to you, and I would expect
Great.
you'll hear something.
Thank you.
Too. And then Ethan asks, he just got his new account today. Where can he go for a basic tutorial? There's a couple websites. I'll put them in. I'll put them in the chat box for you. And Ellen also says, Chris, we're working on finding the right people to help with your Fortran and other questions. So let me put a few websites in the chat box for information about the Science Cloud. This is the site you'd want to go to, which is above.nasa.gov/sciencecloud, and that will take you to a general information page about the Science Cloud. And then you have questions about accessing the Science Cloud. Here's a good website to go to. It's hosted by NCCS, above FAQ page. That one actually is more just above in general, but how to use it. they have a lot on their general on their page. This is that you'd want to go to, which is nccs.nasa.gov/services/adapt, and that will show you user access capabilities, how to use ADAPT, how to access the Windows machines and Linux machines. Also, one other website that is helpful is we have an archive of Science Cloud webinars, and that's this last website here, above.nasa.gov/sciencecloud_archive, and you can see all of the webinars that we have given about the Science Cloud over the last few years, and there are some talks in there that talk about just how to log on, how to what to do if you have questions. If you ever have trouble, you'll want to just send an email to support@nccs.nasa.gov, or you can email me, and we can always get you set up too, Ethan. All right, that brings us about to 2 o'clock. Do we have any other questions that I didn't get to, or that anyone wanted to ask before we sign off? As always, if you have an idea for a topic you want to discuss on the webinar, please feel free to send me an email and let me know. If you ever want to present about the research you are doing on the Science Cloud, we're always looking for speakers to talk. It can be a short presentation, 15 minutes, 10 minutes. It can be longer, and you can tell us a little bit about your research and how you're using the Science Cloud to do it. So we're always happy to have those talks. So thank you all for coming today, and we look forward to our next one. All right. Thanks, everybody.
Thank you, Liz.